Hello Gophers, welcome back to part 16 of Introduction to Go. In this video, we'll be discussing about Structs in Go. Before we move forward, please do not forget to like, share and subscribe to our YouTube channel. Also press the bell icon so that you don't miss on new notifications of the videos that we put forward. So now let's start by understanding what are structs. Structs are nothing but a collection of datas which are related to each other. Let's say I have a struct which is called user, and a user can have multiple fields like user ID, username, father's name, mother's name, address, mobile, email, and whatnot you want to keep in one package. So whenever there is an object, a variable created for that user struct, it will contain all those fields combined together in one single package. So this helps when you have some related data to one single value. So you can create struct for those and use struct. For example, you can use struct in let's say library management system if you are building. So you can have one struct name as books, and our book can have a book sequence number, publishing house, and author's name, number of pages, price, genre of the book, and w- anything else that you feel is related to be captured in one set. So there can be a struct that is there. Now structs are very similar to classes in other languages, but with many differences like it will not allow inheritance, and but there is an alternate to inheritance in Go that is called embedding, and we'll discuss about that in a bit. So now let's start up with creating a struct and declaring some variables of type struct. Now over here I have a struct by name as user, and user contains two fields that are ID and his name. So there are three ways you can create a struct and assign values to a struct. The first one being a normal way when you just create a variable name and you declare the type of struct that it should be and give an empty parenthesis so that Go knows that it needs to assign memory to this variable, and the memory should have the spaces that are used by the inline variables in the struct. Now, after you declare this, you can definitely access all the properties from the struct by using a dot operator. So you give the variable name dot and then the property name that is there inside the struct. So user1 dot id equal to 1, user1 dot name equal to John. Now this variable is also to be considered as a normal string variable, or this can be considered as normal integer variable where you can do all type of integer operations from this variable. So this is not a different variable than a normal int 32. There is a second way of creating an variable of type struct. In this way, you need to have all the values while declaration of the struct. So I have declared a user2 and mentioned the struct type of what type of struct to be used. And then I have implicitly mentioned the name of the key like ID and the value, then the name of the second key and the value. This might look very similar to syntax in a map, but it's a struct, and we don't have a double quote as for the key name over here. We don't have to use that. Now there is a third type of declaration as well possible, but that is highly not recommendable for a production environment application. So let's say I have created a variable user3. Now I will declare it with type user, and I will not mention the name of the properties in the struct. So these properties will be predicted and assigned according to the sequence which is maintained over here. Now, If you go ahead and change the sequence, this should result in an error where it says cannot convert 3 of type int to string, because now this user is having the first variable of type string and it is property name is name. So this is highly not recommendable, because in case there is some changes in this struct, the, the program will break. The program will also break if you include one more field, let's say mobile of type string. Now in this case, when you go ahead and see this program, this part will fail because it would expect one more parameter to be passed. And if you try and run this program, it says too few values in user literal. So we have passed less values in the literal. So you need to go fix the every path of your program so that it remains as it is and does not break. Now, one more important thing that you need to keep in mind, that is when you're using any of these two syntaxes and you add the closing curly braces in the end or in the next line, you should add a comma with the last line end also, because if you don't do it, Go will not Go will give you an error. So we should definitely give a comma there. Now if you go and see this and print this, so over here we get 1 John, 2 James, 3 Ram. Over here, if I can give some characters, so we will get those characters. But if you have observed, we had only changed in this type declaration, but we had no changes in these two, and it gave a default value to the mobile automatically. So that is why only these two types are highly recommended, and we don't recommend this type of declaration using the struct. One more important thing that you need to keep in mind is the naming convention of a struct. In a struct, over here, like I have used the first character as small, this creates this struct private to private or localized to this package, and any package that will import the main package will not have access to user struct. So we have restricted the access of the struct to only this package. But what happens if I have given this uh, struct name as first character as capital? So this will make this struct accessible in other packages where we have imported the main, but there you will not be able to access the property underlying the struct, because those are in small characters. So you need to plan, if you have to expose the complete struct outside the package, then you need to plan to capitalize each property and the struct name as well. Now, if I want to run this, I need to change all properties so that it knows everything now. Now, if I change this and try to run this, it should have no errors and print the same result that we got in earlier output. So we can see we got the same output that we had earlier. So this is one thing that you need to keep in mind. Second thing that you need to keep in mind is struct are value type variables. So let's say I have a user 4 and which I have a copy of user 3, let's say, and I go ahead and change something in user 4. Okay, let's first create this after the first set of print statement. And now let's print only 3 and 4. And before we print, I will print a line after change, so that we have a clear demarcation where we know that what code is printing after we have done some changes. So before changes, if you see, okay, I didn't change anything in user 4 dot id is equal to, let's say, 4. So if let's consider if struct was a reference type, then the user 3 should also get ID as 4. Let's see if that is the true case. If you see, user 3 remains as it is, but user 4 has a change. So that means that struct are passed by value. So every time you pass a struct into your functions or across your functions, you need to keep in mind that there is a new copy altogether created in those functions. So if you have a very large struct and it has, let's say, 1,000 fields, then definitely you should be worried about how to pass a struct. Normally in these scenarios, we will be passing pointer reference to the main struct so that the underlying functions receive only the address of it, and but then that will have an impact on if you change something in the child function, then the corresponding change will be reflected in the parent function as well. So you need to be very careful about that. Now, let's also consider that how we can do embedding that is almost similar to inheritance, but not exactly similar to inheritance. Now, let's say I have a user type created over here, and now I create a type of, let's say, admin, and now admin will have some more properties, let's say, uh, date of joining. And this, for simplicity, I'll just keep as string. Okay. Now this admin should have all properties that were there of in user. But if we have sorry, I skipped the struct keyword. Now if I have one more type, let's say client, this need not have this property. So it will have all properties related to a user, but one more property, let's say uh, company name of type string. So this company name is only valid for a client but not valid for admin, because admin is our employee and we don't care about the company name. Now I want all the properties that are there in user to be there in both of these structs. But that's not possible because we don't have inheritance in Go. Now you can do that in Go using embedding. So I will directly go ahead and embed this in user in the child struct. So just just as uh, this, let's create an object of type admin and let's see how we can do it. I'll remove this this part and I have, let's say, admin version 1 of type admin. Now for admin we have certain properties that are associated with the user as well. So there are two type of declaration that we can discuss over here. Uh, Two major types that we can discuss. So if you see in the intelligence feature as well, we are getting all the properties that were there listed in the user also. So those are ID, name, and mobile. And we have also got the date of joining over here. So let's say ID is equal to 6. Then I say admin person 1, name equal to Sham. Then admin person 1, date of joining equal to today. Here you'll use the date package, the time package to store the date. Right now, for simplicity, I've just stored a string. Similarly, if you go and see client person 1 should be of type client, and I have given an empty struct. Now I will start declaring all the values in it, and it says ID of type 7, then client person dot name of type Raman and so on. But it says some error. Okay, we have not used client one, so that's something that we'll be taking care of now. Print ln. Now in print ln, I will print admin and admin. Sorry, comma admin person one. Similarly, I will say I think I've made some issue with this. Let's print it. It's just giving me an error on client declaration. Okay, sorry, I missed operator over here. Now let's go ahead and run this program. Now if you see for admin we have got 6 as ID, name as Sham, and for mobile we have a space and data joining as today. Now there is an extra parenthesis being printed around the values that were of type user, but that's okay because Go uh, in Go you don't have type of relation as is over here, but it is inside the admin struct, so that's all right. But there is another way of declaring variables of type where you have some embedded type. So let's say I have admin. Now I want to declare all the properties over here. So how we can go ahead and do it? User of type user, and this user will have all the properties to be declared like ID of type, let's say 9, name of type, let's say Sita, and mobile, if mobile is, yeah, we have kept mobile, yeah. So mobile of type some number, then we have date of joining as yesterday's date. So this is how we can also create an variable of type of struct which has some embedded type. So in that, this name property or the property name should be same as the struct that was embedded in it. So it will understand that, yeah, this is something that is of user type and I need to assign it. Now let's run this. So admin 2 will have user as 9, name as Sita, mobile number and date of joining as yesterday. So this is how you can also embed properties inside a struct. Now let's also consider how we can add methods or functions to a struct like there are in classes. So we'll discuss that in a bit. So let's start analyzing what functions do we need for a user. Let's say in user I will remove all this so that we as we don't need all this to be there right now, so that code remains very crisp and we know what we need to do. So let's say it's his first name and then we have a last name as well. So I need a function inside the user struct so that this variable, when adds a dot, then we can access that function. So that these functions that are there residing inside a struct are called methods. And to to create a method, what we can do is func. Now over here we'll say like u and type of struct for which we are creating this method, full name, and this method can return also or accept some parameters as well. It's a normal function, but this keyword, this syntax will only be allowing this function to be executed when you are executing it from an object or variable of that type. Okay, now over here I will be returning a string, and what will be the return? Return u dot first name plus a space plus u dot last name. Now where this u is coming from? U is coming from this place. So whatever name of variable that you want to use, you can use that. Now how can we print this? F name, let's say L. Now I want to only print the full name of the user. So let's say user1 dot. Now we are getting the functions as well. Now I can execute this function. Now let's see what happens. Let's clear the screen first and now run this. If you see, we have got John Smith over here. So this function cannot be executed directly because this function does not exist. This function definition will only exist in the struct. So that is why we can not access it directly. Now, one more important thing that you need to notice over here, that is over here the u that is being passed when we are calling the function is a copy of the actual struct. Now how can we understand that? Now if I change something, let's say id to be like 3 over here, and let's go ahead and print after the first name, function is getting executed. So we'll say new. Now, if this u was passed as a reference, then we would expect the user one in the new part to have id as 3 printed, but it did not. In the same function, outside the function, we got the same value that we have assigned. So this means the reference was not passed. It was actually a copy of the function, a copy of the struct that was passed to it. So this may create some issue of memory overuse. So you can also pass a pointer reference also. Now we'll discuss pointer in a later part of our videos, but over here we'll just give a small hint about how can we achieve like passing the reference to the underlying function of a struct. So we can just add a star in front of the struct name. Now if we run this program, what we will see is the new value will contain the changed value from the function as well. So the function changed the value of id as 3, and that was reflected after running the function that was inside the struct. So this is how you can pass using reference, or you can pass using value. Now that depends on your case to case, where you want to pass a reference or you want to pass a value to the methods of a struct. Now that's all on the struct. Thank you for watching the video. Please do not forget to like, share and subscribe to our YouTube channel. Also press the bell icon so that you don't miss on any new notifications. Also do comment us below on any feedbacks or any new tutorials that you want us to do.